Welcome to Study Loop.
For this problem, we have been asked to show that this equation is true. The floor function of 3x equals the floor function of x plus the floor function of x plus 1/3 plus the floor function of x plus 2/3. Now, in order to do this, I'm going to break this up into 3 different scenarios. And in order to talk about these, I want you to think of x as some integer piece plus a fractional or exponential or decimal piece. So n is going to be integer and e is my fraction. For example, if x was 3.6, well, n would be 3 and my fractional piece would be that 0.6. If it was 4 1/3, 4 is the integer, 1/3 would be the fractional piece. So when I talk about e, I'm just talking about that decimal piece that might be tacked onto x. It could be 0, but it's going to be somewhere between 0 and just a little less than 1. Okay, so I'm going to look at 3 different cases. First, what happens if I have a fraction that is somewhere between 0 and 1/3? And smaller than 1/3. Okay, well, left-hand side, if I take the floor of 3x, well, when I multiply it by 3, when I multiply that fractional piece by 3, it's still going to be less than 1. So it's not going to be enough to push this up to my next integer. So the left-hand side will be 3x. The right-hand side, the floor of x is just going to be x. Again, it's got that tiny little fraction. It's not going to push it over. X plus 1/3. Well, adding a fraction smaller than adding a fraction of 1/3 to a fractional piece of x, which is smaller than 1/3, that's just going to stay x. And my third term, x plus 2/3. Well, because x has a fractional part less than 1/3, even adding 2/3 doesn't push it up to the next integer, so that also will equal x. So 3x equals 3x. Yes, that's true. Okay, now let's go to our next case. I'm going to let e be somewhere greater than or equal to 1/3, but less than 2/3. Okay, so now when I multiply this by 3, the left-hand side, when I multiply this by 3, it is going to put it up to become the next integer, but only by 1. So for example, this could be something like 4.5. That would have a fractional piece between 1/3 and 2/3. When I multiply this by 3, 3 times the integer piece is 12. Now it's up to 13.5. I've added 1 more to it. So I am going to be at 3x plus 1 on the left-hand side. What about the right-hand side? Well, the floor of x is always going to be x. The second piece, I'm adding 1/3. Since my fractional piece for x is less than 2/3, this is not going to push it up to the next integer, so it's still going to be x. My last piece, though, when I add 2/3, that fractional piece is more than 1/3, so I am adding 1. So that floor is actually going to be x plus 1. Those two sides are equal, so yes, that piece is true as well. And for our last one, let's let that fractional piece be bigger than 2/3, but less than 1. Okay, and it's not going to, it's definitely going to be less than 1, because if it was bigger than 1, we'd be up to our next integer. So let's look at that last piece. Now when I multiply by 3 on the left-hand side, I'm going to have 3x plus 2, okay? Because I'm multiplying that 2/3 by 3, it's going to go up. So that would be equivalent to having 3.9. That would be a fractional piece between 2/3 and 1. The integer piece times 3 would be 9, but when I multiply this, I'm at 11.7. That floor would be 11, so I've gone from 9 to 11. I've added 2. Okay, what do I get on the right-hand side? The floor of x is just x. Now, my fractional piece for x is bigger than 2/3. If I add 1/3, that bumps me up to my next integer, so I end up with x plus 1. And for my third term, when I add 2/3, that definitely puts me to my next integer. That is also x plus 1. That gives me 3x plus 2. That case works as well. So no matter what that fractional piece for x is, this works in every case.